So who of you has heard about machine learning? Like, just lift your hand. Okay, everyone, surprise. Next question, so who has heard about adversarial machine learning or machine learning security? Just lift up your hands. Okay, quite a few people, and that's cool because, I mean, this is not a machine learning conference, so it's slightly a different community. And it makes sense because there have been like 10K papers about this as of now, I think. Nicholas Calini keeps a list there. So it is sort of a relevant topic in terms of research, and something, and this happened sort of 2 years ago, that I realized together with Lukas Bieringer, who also did a lot of work with startups, is whenever I approached an organization or a company and started talking about the topic, they were sort of not interested in that. And what we decided together is we wanted to know more about that. So why did people not care if this was scientifically such a relevant topic? So we got help from Battista, Biggio, Michael Bacchus, and Katharina Krombholz. And we conducted a study about this topic. And this is what I want to talk about today. Roughly the outline of this talk, I will give a brief recap about machine learning, which is obviously not necessary since everyone knows about the topic, also about machine learning security. Then I will introduce our sample, and I will talk about the findings that we had. So machine learning. In machine learning, and a quick disclaimer, so I'm talking about classification here, but machine learning security, there's also security issues in data mining, statistics, everything, essentially. So in machine learning, usually you have a task, like in this case, you might have patient data, you want to predict a treatment, red pill, blue pill. So you have this data aggregated. In the next step, you decide about an algorithm, you decide which approach you want to take, having seen your data. Then you have a training phase. So you take the data, you put it into the algorithm, you adapt the algorithm to the data. And then ideally, in the end, you have an algorithm that you can show new data that it hasn't seen during training, and the algorithm will predict a treatment in this case. So adversarial machine learning security. I will explain one attack here, just to give you an intuition how it works. This is a huge topic. If you want to learn more about this, there's actually a free lecture on YouTube from the group I'm working at. So something you can do is you can tamper with the training data. So you compute some changes for the training data, and this affects the training and the final classifier. For example, in terms of performance reduction, or in terms of wrong outputs for a particular subgroup. So for example, what you could think about, if usually the classifier gets, say, 95% of your patients right, you can tamper with the training data, now you're only at 80. Or otherwise, you can also tamper with a subgroup. So for example, now the algorithm gets everything right, but for red-haired people, it will always produce the wrong output or the same treatment, for example. Okay. And as I said, this is one attack of many that have been introduced. There's a huge scientific body of work on this. And then the question is, okay, so what do people in practice think about this? And here, I guess you all know, so I can do a survey. I can talk to many people, quantitative research, or I can talk to few people, qualitative research. We did a qualitative survey here. So we talked in total to 15 participants. This was all in 2020. And although this might sound biased when I say that we had 14 male and 1 female participants, if you look at the overall population of machine learning engineers and workers, then actually 1 to 2 females in the sample would be representative of the overall population. The average age was 34 years, and employers were all European startups. We tried to work with larger companies as well, but unfortunately they denied cooperation. And we had all sorts of different application areas, from cybersecurity, healthcare, HR, pretty much everything. And we also had a wide variety in roles. As you might think, startups are very small. So you might have someone who's at the same time an ML engineer and the CTO of the company. All right, so for the procedure of our study, we had a demographics questionnaire, which we sent up front. They either filled it out before the interview or during the interview before we started. We were generally 2 people. One was conducting the interview, the other person was observing the interview and taking notes. And it was a semi-structured interview where we first asked practitioners to describe their pipeline, then we asked them about the security risks that they saw within their pipeline, and then we showed them 3 attacks and asked them to say if these were relevant and where they saw these in their pipelines. And this included a drawing task, which was done on an online whiteboard, because 2020, COVID, all the interviews were conducted remotely. And afterwards, we used the coding procedure for both the drawings and also the transcripts of the interviews. So let's talk about our findings. In academia or research, for every paper that you can find, you can say, okay, so this is machine learning security, or this is cyber security. Or maybe it's machine learning for cyber security, but so there is a clear distinction, and you can always say what is what. So we sort of expected to see that in our practitioners as well, but it turned out no. So they might start talking about a machine learning security issue and end up on cryptographic keys. So this distinction wasn't quite clear. And before I continue on that, I just want to make a very brief remark about this, because we have essentially no idea what's going on in practice, and this could also be a valid abstraction, but it could also be like a lack of education, right? So there's many different ways you could interpret that. Okay, so what does this actually mean? So how do these two concepts differ and how they were similar? So if we talk about AML mitigations, and they actually have to do the next disclaimer. So unfortunately, we don't really have that many working mitigations in machine learning security, so we counted everything that makes an attack harder. So if you look at who mentioned machine learning security mitigations and security mitigations, then everyone mentioned some form of cybersecurity stuff. So like access control, using cryptography, you name it. But only half of our participants mentioned techniques that actually make an attack harder in terms of machine learning. So there was already a big difference here. And what is also quite remarkable is that whereas threats and security were often taken for granted, in machine learning security, there was always an excuse, including, for example, that there is another team who will take care of stuff, that they have never seen an attack and therefore they don't exist, that the attacker would have a weird motivation. For example, in healthcare, right? People would say a lot, yeah, but if you fool the algorithm that you pretend you're having cancer if you're not, like why would you do that? And also a lot of people, and very interesting, said to have working mitigations, which is actually more people than we counted coding-wise had mitigations, which is sort of interesting. But on the other hand, we also had this kind of overlap where this was not well distinguished for the two fields. And one example for this is the tags for 2 ML attacks and 1 cybersecurity attack. So a code breach would be that your code is obviously breached, so it leaked or something. And on the other hand, we have model reverse engineering, model stealing. These are 2 attacks in terms of machine learning where you are able to copy the model without consent. And what you realize is these 3 things, although they are conceptually very different, actually lead to the same result, which is the model is copied, has been outside, and it can be used by the attacker. And a similar thing, what we observed in terms of co-occurrence of codes, is for membership inference and data breach. And here again, the same as above, you have the machine learning attack, which extracts the data from the machine learning model, and the data breach is sort of like hacking into the computer and getting the data. So it seems to be that in some cases, participants thought more goal-oriented in terms of my data is gone and not so much in how the data actually was leaked. Similar is like sort of availability attacks or DOS, but here even I have to say like the boundary between those 2 things for machine learning and cybersecurity is very, very vague. However, we also have 2 attacks in terms of machine learning security, poisoning and evasion. Poisoning was what I introduced in the beginning of the talk. These don't really have corresponding cybersecurity attacks, and thus there wasn't really like a co-occurrence in codes here. We had another key finding, which was more about the pipeline and how we see everything. So this is like sort of also similar to what I showed in the beginning, right? So we have this idea of a pipeline, we have input data, we have a model, and then we get some output. And then somewhere in there is an attacker. That's what you find in most scientific papers, at least. And it turns out that in practice, life is a little bit more complicated. You might have feedback loops, you have several sources of data which are aggregated, and it's not at all clear whether the defenses and the attacks that we introduce carry over and to which extent. And I would like to give you an example for this. So I said we asked our participants to draw their pipelines. And here, participant 18, you see rather similar to what I showed you in the beginning. There is some data, then there is a model in the middle, and then in the end there is some output, right? So roughly linear, you see in the middle the ML component corresponds to what we have seen. On the other side, on the other extreme rather, participant 16, you see this is entirely different. There is a Python component, there's a Java component, so this is an entirely different level of abstraction. There's virtual machines here. It depicts the entire system. And this is something that we need to keep in mind when we do research, is that in practice, systems are way more complicated than what we consider. And as I said, so it's not clear whether defenses or attacks actually carry over and what it means for these attacks. There are a row of open questions where we found a little bit of things, but we obviously could not find a conclusive answer. This concerns the application. So, for example, practitioners that work in cybersecurity and USML, are they more concerned than some from healthcare, for example? Something we could also not clarify ultimately is the perceived relevance, because we had a couple of people that were very concerned, very nervous. We had other people that were completely sure that nothing could happen to them. So we didn't really get conclusive results there. And also the education, we couldn't really find a good connection to this. And this is actually the point where I shamelessly advertise follow-up work that we've done on that, where we found replies or answers for some of these points. What I personally found very interesting also in relation to what I said in the beginning, so is this actually a thing that occurs in practice, is that we found this one practitioner who had actually experienced attacks. And what they said is, well, we have these highly optimized, super specific attacks in academia that are that alter the input data very, very little. And it turns out this is not really what's going on in practice. In practice, it seems to be more people gaming systems, semi-automated fraud, like trying to get around the system, but not in a very, very smart way, not comparative to what we do in research. But there are attacks already. So let me summarize this talk. So in case that you're a company and you want that your products are safe in terms of cybersecurity and machine learning security, you should either take care, because of what I described, this mingling, you should either enforce that both factors are checked together or separately and then enforce each individually. Then, in terms of the pipelines, I think research would benefit hugely from understanding what is actually how machine learning is used in practice, which kind of pipeline is used, and if our defenses or attacks are actually applicable to this, and what it means for machine learning to work within a larger system. Then, as I said, so we have learned with a study that there are attacks already in practice, but they are not as bad as we might think when we look at scientific research. And then, last but not least, I think it's important to educate practitioners. Because as a matter of fact, we had offered a financial compensation to take part in the interviews. And many practitioners actually said, you know, I don't care about the money if you can give me like 20 minutes afterwards where I can ask you questions about this topic. So it might be good to provide more material than just scientific papers where people can get information. All right, thank you.